Welcome to Lesson 8 in our study of rational numbers, and we will, in this lesson, applying the properties of operations to add and subtract rational numbers. Now these properties of operations are properties such as associative, and again these are in your terminology, on the terminology page at the website. Okay, so we have associative, we have commutative, okay, and those I think will be the ones we'll be using. I mean, there are others, but in this lesson we will be applying the associative property and the commutative property, both of addition in this lesson. Okay. So anyway, yes, welcome to this lesson. I wanted to show you something before we get into it. There is a procedure in the classroom when this is taught in classrooms on a regular basis, mostly at the younger grades, K through 5. And they're called sprints. And what sprints are, they are a time for the teacher to test the fluency of a student in the operations of math, addition, subtraction, multiplication, division. But we will be employing a sprint in this lesson first, lesson 8. They'll show up again in subsequent lessons as well, but like I said, not with the frequency they would in a younger classroom. Okay, so here they are. These are the sprints that we will be working with in this lesson. Now, I won't be working with them here because I can't necessarily time anyone here. Well, I guess I could actually. That might be fun. But I'm going to just count on parents to go ahead and time their students on these sprints. They are to be, children are to be given 1 minute, okay, to complete as many of these as possible. And you can see these are, integer addition, with positives and negatives. There's a round 1 and there is a round 2. Okay, round 1, the kids get 1 minute. They go ahead and record their score here. Round 2. They do their minute, record their score here, and then also record their improvement there. Okay, so this is what we're celebrating. We're celebrating that improvement, and that's the whole goal for sprints is to celebrate improvement. In a classroom, again, the kids stand up. Whoever improved one round to the other. So it's usually the case that every child is standing up at some point in time to celebrate their fluency in math. Okay, so these answers, and I want to show you right now, just to remind you where these answers can be found at the website. The answers to these sprints, or these integer addition fluency sprints. Okay, so here we are at the website, and just wanted to go ahead and show you. So you can, when you come here, just click on the binder answer section, okay, and then we are in rational numbers. And I know you've been doing this already when you're correcting the problem sets. But yeah, then you go here and you just scroll down to lesson 8 solutions. And now on the solutions page, there's not only solutions to the exit ticket and the problem sets, but also keep going down and you'll see this. Okay, here are the solution sets for the round 1 and then for round 2. Okay, these are the keys. All right, so they are there for you to use, and hopefully you will go ahead and use these sprints. You don't have to use them just this once. You can continue to give them to your student. They are well worth the effort. Yes, the classwork for this lesson would have had students um, walking in the classroom and picking a card, and those cards would actually in the front of the classroom there would be a number line. Okay, and this number line would, of course, have the positive section or positive side and the negative side, 0 there in the middle. Okay. And what would happen is that kids would come in and they would take a card, one card, like an integer card that we've been playing games with, and they would have to, within the classroom, find the student that had their opposite card. Okay, therefore, let's say I had a 5. I'd come into the class and I'd be looking all over to find that person that had a -5. Okay, this idea of the opposite, my opposite. Okay, and then we would go, and it would be a sticky note, probably a sticky note, and we would stick it up on the board and find that place. So, for example, 1, 2, 3, 4. In this example, I had the 5, 1, 2, 3, 4, 5. I would put that there, and my 1, 2, 3, 4, 5. My opposite person would put his or her -5 where it belonged. Okay. So after that, we would, as a class, just confirm the fact that we have placed our opposites in different places. Now, these could be rational numbers as well, not just, could be fractions or decimals and such, not just integers. Okay. Anyway, after that, we would use those pairs to talk about this property of addition. Okay, this is one of 5 properties of addition. We talked about this. This lesson was going to be talking about associative property, commutative property. There are 5 actually in total, and other. There's one that's called property of identity. The other one is the property of opposites. This one is called. It's the property of the sum of its opposites. Okay, the property of the opposite of the sum. Okay, we call it the property of the opposite of the sum. Okay, and it is a property of addition. Okay, it's a sort of a rule in a sense. Okay, property of the opposite of a sum. Okay, and what that property states is this right here. Okay. The property states that the opposite of a sum is the sum of its opposites. Okay. Now again, I've been kind of racking my brain. I've been thinking about it, trying to research it, and just to see if it's worth adding any confusion here by introducing this property. But believe me, it is. And if you don't understand its significance at the end of this lesson, don't worry about it. It will prop up its head at some point in your algebra career, most likely this year, again, because these properties are very, very important, and not these properties of additions are important, but even more so the properties of multiplication that you will be encountering this year, and then you'll be using extensively as you move through algebra into 8th grade and beyond. Okay, but anyway, what we would do here is we would put the rational number. Okay, so just randomly a rational number. Maybe we had -5. Okay, and then we had 8. Okay, we would come up with the sum of these. So you have a -5 plus a +8. Of course, is going to be 3. Okay. Now the opposite of that sum is -3. Okay, so that's the opposite of a sum part. Okay, and now the sum of its opposites part, a little bit confusing because when I think of its, I'm thinking of they're talking about this thing here, this sum, but they're not. What they're talking about are the other numbers, these right here, and that's this rational number. So the opposite rational number from -5 is 5. Okay, and the opposite rational number of +8 is -8. And then if I added those, 5 plus a negative 8, you have a negative 3. And you can see these two are the same. Okay, so the opposite of a sum, that was this right here, opposite of a sum, and that's negative 3 is the opposite of 3, is the sum of the opposites. Okay, and those opposites come from up there, and that is the sum. Okay, so the opposite of a sum is the sum of the opposites. I don't want to say its opposites. That's just confusing to me. I think the opposites. Okay, so could do a few more of those. Maybe we will encounter some more of those in. Well, let's do another right here. Okay, I'd love to say, okay, hey, give me one. Give me a rational number. Go ahead, or just give me an integer. We'll just keep it that way. Give me an integer. What was that? It's -7. Okay. All right. Who's got another? All right, 12. Let's do 12. Okay. And let's find out the sum. -7 plus 12 is going to be positive 5. Now the opposite of that sum is a -5. All right. And now we go down here, we take the opposite of that rational number is 7. And the opposite of that rational number is -12. So if we add 7 plus a -12, guess what we get? A -5. Okay. Once again, we could do more. We can more and more of these. We'll have time to practice probably later on in the problem set, I'm hoping. Anyway, just to know that this property will crop its head up again. So please beware. All right, exercise 1. Here's exercise 1. Represent the following expression with a single rational number, which means very simply just add them up, which is exactly what they're saying. Okay, so I'm going to have you try this yourself. Okay, so again, getting used to the language that you're going to encounter in the future. But represent the following expression with a single rational number simply means combine them. Okay, so if you're combining them, you are in this case adding them, finding the sum. Okay. All right, so go ahead and pause for a little bit and give me a few methods, as many methods as you can to solve this one. Okay, of course, as is the case usually, there are a few different ways to solve this. A little bit, of course, a little bit disconcerting for those of us who want to do this quickly because we have, as you notice, we have different denominators. Okay, not entirely different. See, there's two of those rational numbers there contain the same denominator, which is not so bad. But the first way we could do this is we could find a common denominator. Okay, so LCD, it's always good to go for the lowest common denominator, so you have to do less, less simplifying later on. Okay, so I know right away it's 20. 20 as a common denominator. So I'm just going to change this firstly just to, so -2 and 8/20. Okay, so what I've done is I have now converted the 2/5 into 8/20. Okay, and again, something you really do need to know how to do. Okay, keeping my addition sign there, we're going to plus, and then this is going to be 3 and 5/20. Okay, because 1/4 is the same as 5/20. Okay, they're equivalent, just like 2/5 is equivalent to 8/20. Okay, and then we're keeping that sign. Of course, not going to change anything like that. And then 3/5 is going to become 12/20. Okay, so now we have that mess. I mean, there are things we can do. We can combine the whole numbers first, but I'm going to opt to do something different. I'm going to say, in this case, I'm going to say, let's go ahead and change these. Remember, improper fractions are our friends. Despite their name, improper fractions, they do come in handy quite a bit, and you'll be using them more and more as you move forward. Okay, plus. Okay, plus we have then 65/20ths. Okay, and I think you probably know how I'm doing this. Hopefully you do. 2 20ths, that's equals to 40/20ths plus another 8. That's where I got my 48/20ths. 3 whole 20ths. Okay, 3 wholes made of 20ths is 60/20ths. Plus another 6, plus another 5 at 65/20ths. And then here we have 12/20ths. We need to do nothing, so we have no mixed number to mess with. Okay. And now we can, just go ahead and we could do a number of things. I mean, we could actually do this first part right here, the negative 48/20ths plus the 65/20ths. We can even combine the two negatives. Okay, if we combined the two negative parts here, we could combine actually 12/20ths and 48/20ths, both on the negative side. Okay, and we would end up with negative 60/20ths. Okay, negative 60/20ths, and hopefully you can see that they're both negative. Okay, so I'm just combining them because I'm getting a sum here. Okay, getting a sum. So we have negative 60/20ths, then we're going to add another 65/20ths, and you can see very well that will equal 5/20ths because I have 5/20ths more on the positive side here. Okay, it's that positive improper fraction is greater than the negative improper fraction. Okay, now that 5/20ths then simplifies down to 1/4. Okay, so 1/4. So that is one way to solve that. Again, and within that one way, there were several other steps that could have been changed, as you saw. Okay. Now here's another way, and another way we're going to try to emphasize you look for a little bit sooner in the operation. Okay, I'm just going to rewrite the problem here. So negative 2 2/5 plus 3 1/4 minus 3/5. Now we are going to apply apply something called the commutative property now. Okay, we're going to call something called the commutative property. Now again, the commutative property is on the list of terminology for this unit, okay, or this module. So you can go and check that out. But just to know that commutative property, it applies to addition, it applies to multiplication, and it just says that, despite the order of the numbers involved, okay, and the numbers involved we have here is we have a negative 2 2/5, we have a positive 3 1/4, and we have a negative 3/5, okay. So if I were to go ahead and rewrite that right away, I'd want to just go ahead and do negative 2 2/5 plus 3 1/4, and then I want to do plus a negative 3/5. I haven't changed much. I've just made this totally into a sum, okay, which really important, okay. Now, and that's not the commutative property yet, but now applying the commutative property would allow me to do something like this. Nothing ground shaking, indeed, but nonetheless could make our lives much easier. So I would take my negative 2 2/5. Now I'm going to move, okay, I'm going to move that 3/5 closer to this one, the negative 3/5, right? Negative 3/5 right there, and then I'm going to continue to add that 3 1/4 because it's there and it's positive. Okay, so now I need to move that. Put that down there. 1/4. 1/4. Okay. Now what I can do, as you can see, I can combine these fifths right here, these with the fifths. Okay. So at negative, they're both negative, so it's going to stay negative. I just need to add those two together as a negative. And if I do, I get, 3/5 plus another 2/5 is 5/5, which is another 1. So that actually becomes -3. And then plus 3 1/4. And look how easy this is. All right, I've got this -3 and I got this +3. And they're going to cancel out there. And I'm going to be left with 1/4. Okay, and again, we'll do some more of these, of course, just to get some practice. But my question to you would be, which of these do you prefer? I mean, which of these do you think? Well, which one do you think is more challenging? Which one of these do you think is more easier for you to understand? It's always important to ask yourself those questions because you need to use the strategy that is going to work for you, because we all are individuals, but it's always good to have a different way to look at things. Okay, so next we have example 2. This is called a mixed number is a sum. Okay, a mixed number is a sum. Here it tells you use the number line model shown below to explain and write the opposite of 2 2/5 as a sum of two rational numbers. Okay. Now I want you to go ahead and do that. It's going to be something plus something. Okay, and that's what I want you to do right now. Okay, and I will pause, see what you can come up with, write it somewhere over here or something. Okay. Okay, so we can see, and hopefully you can see right away. Just take a look at 2 2/5 on the positive side firstly. Okay, which is probably the easier one. You can see we have, a mixed number is two pieces. All right, and it's actually, a mixed number is a sum of its two pieces, okay? And its two pieces are both what we call rational numbers, okay? They're both numbers. The thing is, we think of as a mixed number sometimes as being one number, like the 2 in this case, and then a fraction, okay? A number and a fraction. Well, the truth is, they're both numbers, okay? They're both numbers, and yeah, we do call the 2/5 part, we call it a fraction, okay? But it is a number of its own. It's a rational number. Okay, it has a place on the number line. Okay, so if we took that 2 2/5, we could write it actually as 2 plus 2/5. Okay, and that's what they've done right here, because you have the 2, and then you have the 2/5 portion. Okay, so you can add those two. 2 plus 2/5. Okay. All right, now. If we use the opposite the opposite of a sum is a sum of its opposites, and if we applied that rule, okay, it might help us out a little bit to understand actually how you would write this. Okay, how you would write this -2 plus 2/5. Now, what this says right here, this is implying that we need to find the opposite of everything that is in that parentheses. And again, if we did that, the opposite of a sum is a sum of its opposites, and and -2 2/5 is the opposite of this number, which is the sum of these two. Okay. So we find the sum of its opposites, and then the opposite of 2 is -2, and then the opposite of 2/5 is -2/5. Okay, so taking this apart right here, right to here we have a -2. Here to here we have a -2/5. This is really important because both of these pieces are negative. Okay, you can't write this as negative 2 plus 2/5 because that's not right, okay? But this is a tendency of kids. What they do is they just apply this negative sign here to the first part of the first number that they encounter. Usually the whole number in a mixed number. They apply it there, but they fail to apply it to the other, because if we again over here, if we use that the opposite of a sum is the sum of its opposites, you can see that much better, okay? Because the opposite of this sum, 2 2/5, we know is negative 2 2/5, right? Okay, that's the opposite there. And the way to get that is through the sum of the opposites that made up that 2 2/5. And so the opposite of 2 is negative 2, and then we add the sum, and then the opposite of 2/5 is negative 2/5. So this would be the opposite. This would be the way to actually write the sum of negative 2 2/5. Okay, writing negative 2 2/5 as a sum. That is how you write it, as a sum of two rational numbers. Okay. Now this is very, very important, and this is going to make, believe it or not, make your life a lot easier in the future. Is this idea that any mixed number can be written as the sum of two rational numbers, taken apart to be written as the sum of two rational numbers. Okay, next let's go ahead and have you try this exercise 2 to kind of practice that that skill or that knowledge that was just given to you by me, and see if you can rewrite each mixed number as the sum of two signed numbers. Okay, this idea of signed means it's going to either be negative or positive. Okay, all right. So two signed numbers, two signed rational numbers, of course. Okay, so go ahead and give that a whirl. Just write those sums right below each of these, A, B, and C. Don't do 3 yet. Let's just work with 2. Okay, so hopefully everyone remembered this little activity over here, and hopefully you took some good notes and they helped you out. Okay, so if we have negative 9 5/8, to write that as a sum of two signed numbers, two rational numbers, that's going to be negative 9. We're taking that apart. We have the whole number part, the whole integer part, negative 9, and it's the sum of. So we're going to add. We're going to add a negative 5/8. That's right. Okay, negative 5/8, because our sum is negative 9 5/8. That's going to take us all the way down to negative 9 5/8 on the number line. 1, 2, 3, 5, 6, 7, 8, 9, 10. Okay, so we're about right here. Negative 9 5/8. Okay, and the way we get there is by adding or finding the sum of. Remember, so negative 1, negative 2, negative 3, negative 4. I just thought of actually showing this on a number line. Just right now. I wasn't thinking to do it before. Did I just do that right? 1, 2, 3, 4, 5, 6, 7, 8. No, yeah, negative 9 there. Okay, so that's negative 9 5/8 right where the arrow is. But that's going to be the sum of that 9, negative 9, and then another negative 5/8. See, so they're both going in the same direction. Okay, they are both negative. Both parts of this mixed number. Oh, I don't want to do that. Both parts of this mixed number, the negative 9 part, and the negative 5/8 part, they are two separate pieces. Okay, two separate pieces, but they are both negative. Okay, both negative. So let me get rid of rid of all this mess here. But I thought maybe showing you that on a number line would help, because what does happen is that, like I said before, a lot of kids they'll go -9 to the left, but then they'll add 5/8. But they add 5/8, they're coming back. Okay, they're coming back, but that would no longer be -9 and 5/8. It would now be what, -8 and 3/8. Okay, because they'd be going back that way. If you see what I'm saying. Okay. All right. Again, a lot of this seems really ridiculous right now. Maybe, I don't know, but I find it fun. Hopefully, some of you are having as much fun as me. But again, it all makes sense to have this to hang your brain on when you see things like this in the future. Okay, so the same thing. This is going to be the same exact situation in B. Okay, here we go. We have the sum of two signed numbers. So we have -2. It's a sum we're going to add, and then we're going to have another -1/2. Okay, so that is, yep, that is that one, and same explanation as before. Okay, now of course this one, easy peasy, because that's 8 plus another 11/12. Okay, so all we're doing is we're taking these mixed numbers and just taking them apart, breaking them up into two pieces, and just applying those pieces down here. Okay, these are both positive because the actual number itself, the full rational number, this mixed number, is positive. And you can see that these are both negative because the mixed number from which they came is negative. Same situation for letter A. Okay. Okay, so exercise C is just asking you to represent each sum as a mixed number, so just working the opposite way around. So if you take a few minutes to go ahead and do that, and check on back. Okay, we're back. So now we are putting these two pieces, these two signed numbers, putting them back together to create a mixed number. I have a negative and a negative, so I know I'm going to have a negative. So that's going to be -1 and 5/12. Okay, it is -1 and 5/12. All right. 30 plus 1/8, easy peasy. 30 and 1/8, and then again -17 and 1/9. Okay, that's all you need to do. That negative sign in the front applies to both pieces, the -17 and the -1/9. Okay, as is the case here as well. And with positive numbers, we need no signs. Okie doke. Okay, so once again, this problem is going to also give you some practice practice with writing mixed numbers as sums. Okay, and hopefully you will apply that to this problem here, this exercise 4. And just let you know, this one may look a bit easier than it is, but again, I'm not saying it's incredibly hard, but if you just do what you know, okay, and look at it carefully as you work your way to that final answer, you'll get it correct. But there is one little trip up lots of kids find themselves succumbing to. So go ahead and solve this, and I'll be back. Okay, I'm back. We'll do this together now, and hopefully have something here. Have a final answer and all your work written out. Okay, so I'm going to read this problem now and highlight some key information as I go along. So Mr. Mitchell lost 10 pounds over the summer by jogging each week. Okay, so I know he lost 10 pounds. That is negative there. It's a -10. I'm going to apply to that. By wintertime, he had gained 5 1/8 pounds. Okay, so here we're looking at plus 5 1/8 because that's what the word gain implies. Gain implies positive, and again, lost implies negative. All right, so represent this situation with an expression involving signed numbers, okay? Involving signed numbers, and you know what those signed numbers are. They're the negative and the positive, which really don't need the positive anyway. But what is the overall, and the final answer there is, what is the overall change in Mr. Mitchell's weight? Okay, so let's lay it out as we see it. Lost 10, negative 10, added back 5 1/8. Okay, there we go, step one, easy peasy. Now, if we can take apart this, this mixed number, or represent it as the sum of two rational numbers, we could just do this. We could do negative 10 plus 5 plus 1/8. All right. So now we're isolating. We got that 1/8 sitting there all by itself. Okay. And now we can go ahead and just take care of this by itself. So a negative 5 plus 5 negative 10 plus 5 is negative 5. And then we add 1/8. Now, can you imagine now what someone might do here that would be wrong? Right here, after this. Okay, so look carefully. Maybe you've done it yourself. Look carefully and see what you have. We have negative 5. We have positive 1/8. They are moving different ways. If I have my my number line, just again, I love the number line. Negative 1, negative 2, negative 3, negative 4, negative 5. Here I am at negative 5. If I'm going to write this summing here, I am at negative 5 here. Okay, there. What do I do now? Which direction do I go when I am going to add this 1/8? I go to the right because it is positive. I go to the right 1/8 of a pound. And where do I end up? I end up at negative 4 7/8. Negative 4 7/8. I've gone back. Okay, I'm adding that. I'm adding that 1/8 to this negative number that I've gotten from the addition or the summing of these two numbers, one a negative, one a positive. Ended up with a negative because my negative portion here was greater than the positive portion. But now I'm going to add a 1/8 to that negative 5, and I'm going to go the other way. Okay, so I'm going to end up here somewhere around there at negative 4 7/8. Okay, so what I've done is I've just 5 minus 1/8 is 4 7/8. Okay, because 4 7/8 plus another 1/8 equals 5. Okay, all right. And what do you think a lot of kids will do? That's right. They will come up with the answer: negative 5 1/8. Okay, that's what they'll come up with, because they see the negative 5, they see another 8, they want to just tack it on, just stick it on there. But what they've done is they haven't added a 1/8, they've actually subtracted the 1/8, because what this would look like would be negative 5 plus negative 8, negative 1/8. Okay, that's what this number would look like, the sum of. Okay, and that does not look like this here. So this is the wrong answer. Okay, this is the right answer. Okay, in exercise 5, what I'd like you to do is to go ahead and we'll read the problem together, but go ahead and look at all the steps that Jamal took, and I want you to, when I say justify, when it says justify each of Jamal's, well, let me just go ahead and read it first. So, exercise 5. Jamal is completing a math problem and represents the expression negative 5 5/7 plus 8 minus 3 2/7 with a single rational number as shown in the steps below. Okay, so justify each of Jamal's steps. Then show another way to solve the problem. Okay, so when I say justify, I just want you to say what he did and why he did it. Okay, so as you can see with step 1, what he has done is right here. This is step 1. Okay, step 1. You notice what he has done. He has actually taken this portion right here and turned it into this. Okay, so what he has done is he has so subtracting. He's applied this rule. So subtracting a number. I'm going to use some shorthand here. A number is the same as adding the inverse. It's adding its inverse. Okay, the opposite. It's inverse. Never going to fit all this in here. Okay, so instead of saying 8 to end that, to end this expression as 8 minus 3 2/7, he's just created it all as being a sum. The entire equation right now is or expression is all sums. We have a negative 5/7, we are adding that to 8, and then we are adding negative 3 2/7 to that. Okay, kind of separates everything out. Okay. All right. So and next we see he's done here. What he has done, he has actually applied the commutative property. Okay. What he has done, he has switched. I'm just going to erase this here because this is a little messy, so I can see here. So he has moved these two. He's moved that negative 3 2/7 there and moved the 8 to the end, okay, because he wants to put these two closer together so it's easier to work with. So he's applied the commutative. Okay, and I'd love, if you didn't do this, I'd like you to oh, actually, you haven't done. I haven't let you go, have I? Okay, I'll let you go. But okay, we'll just do this together. So he applied the commutative property, or how about prop of addition? Okay, that's what that one is. Yeah, I was going to do that first as an example for you, and then I just kept going because I'm having so much fun. But no, this is something good for us to do together. Okay. Yes, a second step, he applied the commutative property. All right. Now in number 3, step 3 here, you can see what he's done. He applied the opposite of a sum is the sum of its opposite. So the opposite of a sum, property. Okay, it's also a property. All right, and you can see what he's done is he's just taken these mixed numbers right here and taken them apart, okay, and made them into the sum of two rational numbers. Okay, so the 5 5/7 becomes separated, and it becomes negative 5 plus another negative 5/7. Remember, they're both parts of that mixed number are going to stay negative because they are negative. Okay, and then he's taken negative 3 2/7 and done the same, and turned that into the sum of negative 3 and negative 2/7, and of course left the 8 by itself. Okay, left the 8 alone. All right. So again, I'm just going to get my eraser here. Erase, just so we can keep it clean. Now, step number 4, you can see what he has done. He has done a little bit more commutating, or commuting. Let's say commuting, when you move from one place to another, and he's actually commuted the 3, put it back there now to be with the 8 next to the 8, and then the 2/7 over here to get that next to the 5/7, so they can be combined a little bit more easily. Okay, commutative again. Okay, in step 5, and now in step 5 he has applied what we call the associative property. Okay, the associative property, and what he is doing then, he is going to go ahead and add those, add the fractional portions right here. Okay, add the fractional portions, which are these two here. Okay, the negative 5/7 and the negative 2/7, and that is going to become negative 1. Okay, they are no matter which way you added those, whether they be negative 5/7 plus negative 2/7 or negative 2/7 plus negative 5/7, they are going to always equal equal negative 1. Okay, that was probably not as clear to you, but we'll look at that again. Okay, we just added those two actually. And what's really nice about this, when you change up here, this step number 3, when you make everything as the sum, as sums of whether positive or negative numbers, really makes it so much easier. I'm not worrying about what sign is in between. I'm just worrying about the actual rational numbers themselves, and it's real great. I'm just combining. So if I combine negative 5/7 and negative 2/7, I have a negative 7/7, which is also negative 1. Okay. And now it's really nice to have all I have all whole numbers. Okay, I have all whole numbers now in front of me. Okay, and here they are. Number 6, step number 6. What I'm doing is, well, what he's done, or whoever's done here, is that just went ahead and just combining numbers a couple at a time. So in number 6, he just combined the negative 5 and the negative 1, and again that plus sign, that sum sign, just means to combine, and that gives me that negative 6. Kept my negative 3 and my 8. All right. Next to step 1, more combining, and we then are combining the. Let me just erase this here. We're combining our these two, negative 6 and negative 3, and we get a negative 9. And then put the 8 back down. That's 8. Then our last combination, and we end up with negative 1. So we didn't talk about a second way or an alternative to complete this this problem. Not sure how you guys did it, but here's my my process right here. You can see we started. This is the starting point right here, and then my step number 1, I went ahead and applied the sum of its, no, actually not sum of its opposites, but the commutative, just moving things around, just moving that negative 3 and 2/7 next to the negative 5 and 5/7, and then I applied the sum of the opposites here in step 2, separating those out, okay, as we've seen already before. And then I went ahead and just applied the commutative, just moving things around. Just what I did though this time is I put all of the whole numbers right next to each other, the negative 5, positive 8, and then the negative 3. Okay, all those together, and I put the fractions right next to each other, negative 5/7 and the negative 2/7. Okay, and when I combined all of these, negative 5 and negative 3 is a negative 8 plus an 8. Okay, sum of the opposites is 0. Okay, in that case, that is 0. And then adding negative 5/7, negative 2/7 is negative 7/7, which is negative 1. So, in a sense, I think I did about 4, maybe 4 or 5 steps versus 8 steps for the other person.
Okay.
Okay, so to summarize here, what we've looked at, well, the key points we looked at in this this lesson 8. number one, using the properties of operations to add and subtract rational numbers more efficiently, I guess is a good idea. Okay, yeah. All right. Yeah, use the proper properties of operations to add and subtract rational numbers more efficiently. I'm sorry, I kind of read that wrong, but yeah, that's how I use those properties of operations. Remember, those were the ones we talked about a little bit in here were commutative. Probably a new one to most of us were the sum of the opposites, which was great, and we had associative in there, and yeah, and others as well, and yeah. But use those properties of operations, and this is the key to make it all more efficient. And again, as you encounter more and more complex problems, these properties will help you more and more. Okay, and again with the this one here, the properties, this one property of operations right here. Look what we have: 5 2/9 plus 3.7 plus 5 2/9. Okay, and then what we do is we'll go ahead and just recombine with the commutative property right here. Put these together. Left this one on its own. Okay, and then you see right here, these two actually cancel out, and then that is left by itself, and you get that answer. Okay, so instead of trying to just beat yourself on the head over and over again, and trying to add these two first, and changing that to a fraction or that to a decimal, blah 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 blah. Sometimes you can very easily just move things around, commute these numbers in addition and multiplication. They commute very, very efficiently. Okay, they'll move around and they won't mess you up. Okay. And now the second one here, which I really like, probably new to most of you out there, the opposite of a sum is the sum of its opposites. Okay, which is again this word efficiently, much more going to help you be much more efficient. If you look at -4 and 4/7 is actually the sum of its parts there, and then this negative and then 5 plus 3 is actually -5 plus -3, because that negative sign applies to both parts of that number. And again, when you apply these rules to the problems we've been doing, you'll see that'll make you much more efficient and make you a happy person. All right, happy camper. Okay, so that's it for this lesson. It was a little bit long. It's meant to be long. Hopefully, lesson 9, which will be the last one for this week, will be a bit shorter. Okay, and if you've stretched this out over the course of a couple of days or a day and a half, that is, of course, fine. All right, so I hope you had fun. Enjoy the exit ticket and the problem set.